The entire destruction workflow can be greatly improved by having some good proxy geometry to work with. Now, prior to Houdini 17, this was pretty difficult to generate good proxies. We didn't have decent ways of generating some simplified geometry that only put the detail and resolution where you need it. But now in Houdini 17 Plus, we have the convex decompose available. So here I've taken the fracture geometry and I've just temporarily used my measure fracture node to remove most of the pieces. In my case, I'm using a size threshold of 12 on the bounding box size just to isolate a handful of pieces to test with. It's good to use just a few pieces, preferably pieces with a decent amount of shape variation like this, to test out your convex decompose settings. Because sometimes that decompose process can be pretty slow to run on your entire asset, so we want to find settings that we like with just a very limited number of objects first. So now that we have some test objects isolated, drop in that convex decompose, hook the unpacked geometry up into that, and check out the results. Now this has to be unpacked geometry. If we try passing the packed geo into the convex decompose, you'll see that it doesn't do anything. So make sure you're always putting regular unpacked polygons into that convex decompose sup. So you can see by default this is just giving us some very primitive representations of our shapes, and this convex decompose sup uses a very simple control set to control the level of detail in these proxies. This max concavity option is the primary one that we're interested in. By default, it has this very helpful piece name attribute checked and set to name, so that it'll create a different proxy for each piece as indicated by that name attribute. So that's very important to do this as a per piece operation. And then we can just start controlling this max concavity amount. I'm just going to turn it down to 0.5. You can see that gives us a much closer representation than a value of 1 does. And we can go a little bit lower. Maybe I'll try a value of 0.2. And to me that looks like a pretty good level of proxy representation. It gives us a pretty good representation of the shapes of our actual geometry without giving us too many individual pieces and too much resolution to work with. The decompose also gives you this segment attribute, which is a different number for each one of those convex hulls that make up the overall per piece proxy. And I don't think we'll really need to use this segment attribute very much, but we can still keep it in there in case it's useful later. Once you've picked some convex decompose settings that work well for your test pieces, you can run it on the rest of your geometry. However, if there are pieces that you don't want to run the decompose on, that's fine, and you can optionally choose to skip certain sections. For example, in my case, I've added the split for the window frames to split those out based on their name, so that we can just use the window frames as is. There isn't a ton of resolution in those window frames already, so I'm confident that it's pretty okay to use those in their current state for our simulation. But that said, if you'd like to, you can feel free to include your window frames in the convex decompose as well. The decompose is pretty slow. In my case, this took more than 10 minutes to run on the entire geometry. I think probably it was closer to about 15 minutes. But even if it's a bit slow, it's still absolutely worth it to have this decent proxy representation of our fractured geom. Now you'll notice that we're getting a warning on our merge because our inputs are quite different. We have raw polys from our convex decompose on one side, and on the other we have these packed window frames. So just to keep it consistent, I'm going to run an unpack on those window frames. And then to make sure that the attributes are consistent between our two sets of geometry, I'm going to add a segment attribute to the window frames as well. Since we're not doing a decompose on our window frames, I'll just add in a primitive wrangle, and we'll set an integer segment to a value of just -1 on all of our window frames. So say I at segment equals -1. And now that warning on the merge goes away and all of our geometry is consistent, and we can pack up this geometry like we did with our regular fracture. And as before, we'll turn off the path attribute option, turn on the name, and we'll need to transfer some attributes. If you want to make sure that the same attributes always get transferred that we're transferring on our fracture geometry, you can select the fracture geometry's pack node, and we will copy the transfer attributes parameter and paste that relative reference for our convex decompose version, like so. Just paste in that relative reference there, and we'll make sure that if we change the promoted attributes on the upstream fracture version, that we get the same attributes from the decompose. And one of the nice things about how this convex decompose works is that it will maintain the attributes on this decomposed proxy that you had on your original geometry, so we don't lose all of that info. Now, as one last little step on our proxies here, I'm just going to add a normal node because we do have some slightly weird normals across the surface of those proxies, and that's not necessarily a problem. This is an absolutely optional step if you'd like. I'm just going to give this some sharper normals just so that our proxies display a little bit more nicely. Now finally, we can add our proxies to our RBD pack, and we can cache out this final output. So I'll just create a file cache node and hook that up to our RBD pack. We'll set this to just save the current frame and always turn on that load from disk option, and we'll set the path to our job location and caches, building RBD, and I'm calling this fracture filtered. So you can set that, you can call it something different if you'd like, and then save it to disk, and we now have our nice cached out, packaged up, and destruction rigged asset. And then so that we can refer to this in other sections of our scene, we'll just add in a null node after that file cache, and we'll call this out fractured.